Hey everybody, Mr. Bamber here. This is called the Vertex Method, and it's already in factored form right here, and we're going to graph these. These go pretty fast. I like this one almost the best on graphing these. In fact, I do. It's the quickest way. All right, so let's go ahead and graph these guys. So what I'm going to do is just find the intercept, set that equal to 0 and set that equal to 0, and that tells me where it goes through the x-axis. That's the intercept. So here at -1 and +5. When I set x plus 1 equal to 0 and x minus 5 equal to 0, I get -1 and 5. All right, that's easy enough. I know it's going through those 2 points. The axis of symmetry is right in the average. It's in the middle of these two guys. So this is 6 across. So just go over 3, and so the axis of symmetry is x equals 2. So now to get your vertex, you guys, you plug in x equals 2 right there and crank it out, and that's going to get me my y. So 2 goes right there, and it's going to equal this y. So I get y equal to 9 when I do that, because I get 2 plus 1 is 3, 2 minus 5 is -3, so it's negative times 3 times -3 is going to be a positive 9. So it's up here at 9 right there. There's my vertex right there. Boom. Okay, and then remember, you go over 1, it goes down 1 squared. Over 2, down 2 squared. So from the vertex over 2, 2 squared is 4, down 4 on both sides. Check it out. Over 3, down 3 squared, which is 9. All right, so there it is right there. Okay. All right, so this one, graph this guy right here. Okay, this one factors. You can do the lesson that we did last time. I know it's going through -2 right there. I'm going to show you a new way. I'm going to factor this guy. Okay, pull a 2 out of both those guys, and you get x squared minus 1. Remember from the last chapter, it factors to a difference of squares. X plus 1, x minus 1. This is a difference of squares. Okay, so my vertices are -1 from this one, +1 from that one. Okay, and then so my axis of symmetry is right up the middle right there. I'm going to plug in 0 right there, and then I get 0, -2. Okay, and then over 1, it goes up 2 times 1 squared, 2 times 2 squared. This number right here times 3 squared, 4 squared. So if I go over 2, 2 squared is 4, it's going to go up 8, which is up here at 6 because it's down there at -2. I don't think I graphed this one, but if I went over 3, 3 squared would be 9, but 2 times that would be 18. Yeah, I know I didn't graph that one right there. Okay, so there it is right there. Go ahead and connect them. All right, and then let's try another one. Y equals 3x squared minus 12x plus 12. Okay, I can pull a 3 out of all of those. I'm going to factor this, and then this is a perfect square trinomial. Gives me a binomial squared. Remember that from chapter 9? Okay, so this only has one x-intercept at x equals 2 when I set that equal to 0. All right, so if it only has one x-intercept, that's the vertice right there. So over 1, it's going to go up 3 times 1 squared, 3 times 2 squared, 3 times 3 squared. So over 1, up 3 on both sides. Over 2, 2 squared is 4, but 3 times 4 would be up 12. I think I did do that, you guys. Okay, axis of symmetry. Yeah, there I did. Okay, there it is. All right, that's a beauty. Isn't that a beauty? Makes you all smiley, huh? Okay, now that first one, the max, it had a max at 9 because it went down. I'm just reminding you about maxes and mins. I probably should have done that during the lesson. On this one, this graph had a minimum at -2. It's always your y coordinate of your vertex right there. And finally on this one, this had a minimum of y equals 0. Okay, it's always your y equals of your vertex.